Hi, Henk Akkermans here. Supply Network Dynamics, Session 1, Example 4. We ended Example 3 with a very interesting, perhaps even beautiful behavior of our system, but not the one that we were looking for. We were looking for ways of making the fluctuation, the oscillation as it's called, in the system disappear, or at least become a lot less. We keep having this fluctuation between the amount of work and the capacity available, and it should be so simple. What we looked at was at ways of making the target lead time appear shorter, because that seemed to be a very good way of making sure that customers got their stuff in time, and so we wouldn't have a lot of oscillation. But it didn't work out that way. In fact, actually what happened was that we got a lot more fluctuation the shorter our target lead time became. We became more nervous. Another area you may want to look at is, let me get some of these graphs out of the way, is the change delay, because that's another parameter. Let me clean up these graphs. One way of doing that is by clicking on here on the dynamite. Another more thorough way is going to model, restore all devices, and then you have all of them. We're going to change the change delay. I'm not quite sure if we should make it slower or faster, so a smaller number or a bigger number. But let's try both and let's see what happens. Let's see if we, what if we change the change delay up here, do 4 runs in which we start with, start with 2, which is a shorter delay, and end with 8. How about that? What happens then? Let's run. I just pressed the R button here because else my graphs disappear. So this is the first one, and that's a very short capacity change delay. That looks really good. So there, it may be a good idea to have quick adjustments, because 4, this is our base case, is more, 6 is even more fluctuating. And I suspect that the 8 will be even worse. Yep. So if I change the target lead time, if I make that short, the oscillation increases. If I make the change delay short, the oscillation decreases. This is a very long change delay. And this only illustrates how very complex the dynamic behavior of these systems can be. Still, we are looking at a second order nonlinear differential equation, and those can be tough nuts to crack.